Today we are going to talk about chapter 4. So let me share my screen with you. Okay, here's the NumPy basics. This chapter name. That is this chapter's name. So um, let's check the first one, which is the NumPy ND array, which is a multi-dimensional array object. So one of the key features of NumPy, sorry, it's NumPy, not NumPy. NumPy is its n-dimensional array objects, or ND array. So it is a fast, flexible container for large data sets in Python. Arrays enable you to perform some like math operations on whole blocks of data using similar syntax to the equivalent operations between scalar elements. So I think for me, it really looks like to create a matrix here with NumPy. So let's start, which is ND array or y, right? And then how to create this ND array, what we will do is to, okay, first to import numpy as np, and then we will go to data is equal to np dot random dot rand n 2 and 3. This is a parameter, and what's in data. Okay, so this is data, and there are 2 rows and 3 columns. So then we can write mathematical operations with data. With this, should say actually it looks like a matrix. Data, which is multiply with 10. And you can see the result is everything in data is multiplied by 10, right? Also, we can do, what we can do is to, okay, we add data with the data, and here's the result. So in this example, I mean, for this one, you can see all elements have been multiplied by 10. In the second, the corresponding values in each cell in the array have been added to each other. Then an ND array is a multi-dimensional container for homogeneous data. That is, all of the elements must be the same type. So we cannot put different types in it. For example, in list, you can put different types of data in it, but in ND array, you cannot do that. So let's go to the next step, which is creating ND arrays. So create ND array. So the easiest way to create an array is to use the array function. This accepts any sequence-like object and produces a new NumPy array containing the past data. So what we can do is to, okay, first we have a list, which is called data, and then in it 1, 2, 3. So what we should do is IR1 is equal to np dot array, and then data1. Right now we change it into, so what is array1, and let's check the type is of AR1. Okay, it's ND array. So that's how we create that. We can see right now this ND array is one row, but one row, 3 column. And then we can see what is like nested. We can also put like put multiple lists in np.array wrapped by np.array, and then we can create an ND array. So here are some, for example, here we have data 1 and then we have data 2, right? Okay, there is a condition that we need equal length lists. So this is this, and then we do an array of the data 2. Okay, so what we need to do is like this. Okay, we got this array and the array. At the same time, we can check array dimensions and shape. So and then check this and check the shape of it. Okay, this is a shaped row, 3 columns. So let's check the next thing, which is, okay, we want to know AR1's D type. This is D type, they are all integers. And the next thing is that there are also other functions to create new arrays. So for example, np.zeros and np.empty and like np.arrange. So these are the other ways to create array. Actually, there are a lot of other ways to create array. I will not talk more about that because actually you can search it. So I think it's best to remember the basic way to create an array, then that is okay. So right now, let's look at the data types of the arrays. We have mentioned that, okay, we have mentioned that all the data in array should have the same data type, right? So, but we can also assign a data type. Assign data type to an array. We have I should say we have a parameter here we can set, which is a special object containing the information the ND array needs to interpret. So we can say D type is equal to np.float. Then let's check D type. Okay, no result. What happened here? Okay, I think it's this. See, it turns into float. So D types are a source of NumPy's flexibility for interacting with data coming from other systems. In most cases, they provide a mapping directly onto an underlying disk or memory representation, which makes it easy to read and write binary streams of data to disk, and also to connect to code written in a low-level language like C. The numerical D types are named the same way. A type name like float or integer, followed by a number indicating the number of bits per element. A standard double precision floating point value takes up 8 bytes or 64 bits. Therefore, this type is known in NumPy as float 64. So there are also another ways for you to set like integer, float, complex, boolean, string. Okay, so let's go to check the next thing, which is to arithmetic with NumPy arrays. So arithmetic with NumPy arrays are important because they enable you to express batch operations on data without writing any for loops. NumPy users call this vectorization, and the arithmetic operations between equal size arrays applies the operation element wise. So let's check what's the meaning of that is. Okay, actually is you can like add two array together. You can multiple two array together, and then you can actually anything you can think about. So that is what you can do with array. And the next thing I want to talk about is basic indexing and slicing. So this part actually, yeah, we need a lot of time to look at that. So I will, this part I will end here. So we just talked about some like how to create ND arrays and data types for ND arrays, and also arithmetic with NumPy arrays. And the next part we will talk about basic indexing and slicing. So that's all for this part, and I will stop sharing and see you later.